Okay, so if you want the section and the name, polygon. The word polygon describes a certain group of figures. And those figures are closed, and they're just flat. They're in a plane. They also are formed by 3 or more segments that join at the endpoints. So in other words, every side is a segment, a straight segment. They don't cross over each other. We're drawing pictures of some polygons. Polygon could simply be, I'm trying to draw it straight. That's a polygon. And a triangle's a polygon. It said 3 or more. A polygon could be, I'm trying to make sure I go straight. Some random, this one kind of looks a little curved. A random shape. That's a polygon. Straight sides, closed. Segments connect just at the endpoints. Well, then down on the bottom of the screen, sides are the segments that form the polygon. So just like a triangle has sides, a polygon's going to have sides. Could have more sides than what a triangle had. And a vertex is the endpoint of the sides of the polygon. So in other words, the corners. That's the vertex, or vertices, or a polygon. So what's the difference between a triangle and a polygon? Not really anything, because a triangle is a polygon, but there are other polygons that are not triangles that would have more sides than what a triangle has. So a triangle would be the polygon that has the fewest number of sides that could be possible. We don't have a symbol for all polygons. We did have a triangle symbol. But when we get to 4-sided or 5-sided or 6-sided, we'll use their classifying word instead of a picture in order to tell what kind of shape it is. The names. Anyone still need the screen? Okay, so is this first figure a polygon?
No.
Why not? It's not closed, correct. There's an open space. Is the second one a polygon? Yes. Closed, flat, straight sides, correct. First one? Yes. Second one? Why not? Right, it has a curve to it. Not a polygon. Now when we name a polygon, we're going to list the vertices in consecutive order. What's consecutive? The way it goes around might not be alphabetical. It might not be like the alphabet, but just as you go around it. So if I start at D, this would be polygon D, let's go this way, C, B, A, E. You don't repeat the D, but knowing it's a polygon, you'd have to close it up. Right? Or it could be polygon D, E, A, B, C. I could start at E. I could go E, D, C, B, A. Or I could go E, A, B, C, D. So going in consecutive order rather than jumping around. So give me a proper name for the one on the right. You have to raise your hand so I can listen to these carefully. Tom, give me one name.
RXUT.
Correct. Lizzie. SRTU, yes. Here. Yes, UTR, correct. How many correct ones would there be? Yeah, how many places could you start? There's 4 different choices to start. So if I choose starting at S, then there's how many possibilities? 2, because I could either go clockwise or I could go counterclockwise to name it. So 2 from S, 2 from R, 2 from T, 2 from U. There would be 8 possible names for that polygon. So naming it is listing the vertices in order. How many names would there be for this one on the left?
10.
It would have been 10, correct. Right. A diagonal. A diagonal is a special segment that joins 2 non-consecutive vertices. Joins 2 non-consecutive vertices. We'll have our notebook check, I think we decided Thursday, where you'll have to find certain things in your notes. We don't have a test this week, but, well, I guess a chapter test we don't have. I probably should write our schedule over here. We talked about doing a cumulative test, and you told me Wednesday would be your preferred day.
That's in class.
Yes. And it will be open notes. Some of you think, oh, good, it's going to be easy. No, that doesn't necessarily mean easy. What that means is you might have to look some things up to do well on it, that kind of thing. So we'll do lesson 6.1 today, 6.2 tomorrow. Then we'll do our cumulative test, and we need to do our notebook check on Thursday. And we'll see what other things we need to finish up. And this is a Pi Day. Well, it's actually not Pi Day. Saturday is Pi Day. What I mean by Pi Day. It's 3/14. You don't have school on Friday or Monday after that. So March 14, the year is 2015. 3, 1, 4, 1, 5, 9, 2, 6, 5, 3 maybe? Blah, 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 keeps going. So it's a special Pi Day this year even, because the year fits into the sequence of numbers. So instead of just celebrating March 14th, we can celebrate March 14th, the year is 15. At 9:26, either in the morning or evening, I don't care which one you want to celebrate. 53rd second. Yep, you can celebrate it twice that day. So that's what Pi Day is. So we'll maybe do a little bit of celebrating since it's a special Pi Day this year. Anyone going to bring some pie for us to really eat?
Well, I made cake, so
Okay, we'll only need pie.
I can make a cake in the shape of a pie.
Cake in the shape of a pie. In other words, round?
Yeah.
All right, let's draw some pictures of a diagonal. So we'll see, maybe we'll get, I will try not to have homework for you Thursday. But I think if we don't do any lesson that day, our test is gonna end up on a Monday.
I would be okay
Oh,
with
okay.
that.
We're okay with that?
Yeah.
All right, we'll make it work. All right, so let's draw a polygon here. I'm going with 5 sides. And I'm going to switch colors and let's put in a diagonal. A segment that joins 2 non-consecutive vertices. Let me label. Which ones are consecutive? Well, AB is consecutive. So AC is not consecutive. So if I connect those, I just now drew a diagonal. Does that look like it cut it in half? No, diagonals don't necessarily cut it in half, but that's a diagonal. Any other diagonal from A? AD would be another diagonal. Okay, how about from E? EB, BC. Notice DB is another diagonal. I've got all of them drawn in there. Yeah, that one kind of looks like a star on the inside. Okay, you draw that was 5-sided. How many diagonals did we draw there? I think there were 5 diagonals, correct. Okay, you draw 6-sided on your paper. 6-sided. It doesn't have to be symmetrical. 6 sides. Now draw and count. How many diagonals are you getting? Diagonals again. Got 8. How many diagonals are from every corner? 3 from every vertex. That one. Not consecutive. Okay, there should have been 9 diagonals there. Now there is a pattern. You'll notice that from every corner there were 3 diagonals. 3 from this one, 3 from that one. So if there were 6 corners and there's 3 diagonals from each, shouldn't there be 18?
No, you can't count twice.
Correct. No, because you're counting, if you count it on each end, you're counting that diagonal twice. So if we would take how many sides there are times how many diagonals at every corner, but then divide that by 2, that will tell you how many diagonals there are. So let's see if we can predict on a 7-sided. So draw a 7-sided, try not to make it cave in, makes it confusing. Try and get it to go out. If you can figure out how many diagonals from one corner, we can figure out how many total diagonals there are. 7 sides to start with. Straight up and then we'll get rid of that. So this outside. Okay, how many diagonals from one corner on the 7-sided? Figure that out. 1, 2, 3, 4, 5, 6, 7. Okay, so if I go from this, oops, sorry. If I go from this corner, I can draw 1, 2, 3, 4 diagonals. Okay, so how many corners are there? And there's 4 diagonals from each one. That's 28 total, but we said we don't want to double count. Divide by 2, so there should be 14 diagonals. Alright, so a lot of diagonals in those shapes. Okay. Thumbs up or down if you understand diagonal, what a diagonal is. Alright, moving on. That's what we just talked about, how many diagonals in the polygon. Okay, classifying the polygon. Classifying is different than naming. Naming, we're listing like A, B, C, D, E. But classifying is using the specific polygon name for how many sides it has. Some of these you probably know. There are others you're going to need to work on. You need to know all these. So a triangle is a polygon with 3 sides. That would be the definition of a triangle, or a definition. Quadrilateral. Quad means 4. So that is a 4-sided polygon. Pentagon. 5-sided polygon. Why was the building in Washington called the Pentagon? It is called that because it has 5 sides. When you look from the top of it, it's like 5 walls. Not if you were standing on the ground and looking at it, you wouldn't be able to see the Pentagon. Right. And the wall you're looking at would be a rectangle. So it'd be hard to visualize. But yes, at a certain angle, you could maybe see 3 walls maximum. The Pentagon, probably, if you're on the ground. Usually, or mainly because it's kind of uncommon. I'll tell you what it is. I'm not going to force you to memorize it, but it might be a bonus kind of thing. Okay, a 9 is a nonagon. And a couple more that I throw into regular geometry. 11 is an undecagon. Un or undecagon. And 12 is a dodecagon. Now, how I remember those two is it seemed to be kind of a Spanish connection in my mind. What's uno in Spanish? 1. And what's decagon? That's 10. So undecagon, in my mind, is like 1 plus 10, so 11 sides. And then, yeah, 12. Do reminded me of dos. So dos plus deca would be 12. So I will mention those to you. I won't have that on an actual quiz or test question, but I might throw these green ones as like some bonus. Right, where was I on my list? 5 was pentagon, 6 is hexagon, 7 is heptagon. Now you have to spell those close enough that I know whether you mean hexagon or heptagon. You can't go hextagon. I'm not going to count that right on either one because I don't know which word you want. Okay, then octagon, which would be easy to remember because, okay, stop sign. I was thinking octopus with 8 tentacles.
I was thinking of the cartoon of the latest one, Oslo, because he's in the shape of an octagon. Octopus.
Okay.
Actually, there's a few episodes in the shape of an octagon when we're learning about shapes.
All right. And the decagon, decade, 10 years, 10, so that prefix is deca.
How do you draw an octagon?
How do you draw an octagon? Nonagon, okay. Probably for any of these, one way could be start with a circle, and if it has 9 sides, it's going to have 9 vertices. So put 9 dots on that circle, and then connect one dot to the next.
what's that end
Oh, good question. So what's n-gon?
Yeah.
That is the general way that we will do things from 10 on up. Are there names for an 11-sided, 12-sided, 13-sided, 14-sided? Yeah, there are. And rather than have you memorize all of those, what we will do at the end then is say a 15-sided polygon, it's a 15-gon. That's a 15-sided polygon. 20-sided polygon is a 20-gon. So that's what that n-gon. N is just the number of sides, and we use gon to indicate it's flat, it's closed, straight sides. Okay, let's go to the next string. Okay, so I'm going to draw a figure up here. You decide whether the figure is a polygon, and if it is, you're going to classify it by how many sides. If not, explain why. So grab your marker board. So first, yes or no, and then that'll direct you as far as what else you need to do. Okay, first one. Is that shape?
That's a circle.
Answer the questions. Kind of a bad circle. Alright. So I should be seeing, no. Why is it not a polygon?
Because it has no sides, it just goes on.
Correct. It has no sides. It's made out of curves, so that was not a polygon. Okay, let's go with. Okay, decide whether it's a polygon. If so, classify it. If not, explain why. All right, this one should have said yes, pentagon,
Lack of clue.
5 sides. Okay, next one. Polygon or not, classify or say why. Okay, show me those that have the check. Count the sides again, guys. What kind of Natasha? It is an octagon. Counting the sides. 1, 2, 3, 4, 5, 6, 7, 8. Should have been 8 sides. Octagon. Okay, let's go with. Correct. Okay, I saw yes. All right, so that was no because of the curve. Okay, let's change it then. Trying not to curve it now. Okay, I think those are all straight sides as they're supposed to be. And I did try and close it. Somebody's gonna be real close. Yep. Okay, Sam, what kind? Hexagon, correct. All right, hexagon.
Okay.
Hexagon. Okay, I think you got the idea on that one. Okay, so a precise way to name the polygon is to give its classification and then list the consecutive vertices. So name this one completely, kind of like its first name, last name. So classify it based on how many sides. Then pick a vertex to start at and go consecutively around it. Either clockwise or counterclockwise. There's no way I'm gonna be able to check these completely, so don't erase it. Don't erase it. What's the classifying word? It should be heptagon. If there was 1, 2, 3, 4, 5, 6, 7 sides. So heptagon, and then if you started at S, maybe you went heptagon S, M, N, O, P, Q, R. And it's hard for me to remember as I'm looking at yours to try and do them right. So S, S, R, Q, P, O, N, M. All right, so I'm going consecutively around. All right, we're not using clickers. Okay, we're going to do an exploration. All right, and I think you need protractors. So let's see if we can get packets that have protractors. Toss them. Okay, how about first person come and get some for your roll? Try and find some with those protractors in them.
Oh, wow.
Okay, everybody get a protractor and a straight edge.
Oh, yeah.
And it probably would work best to go on a sheet of paper. I don't know if the marker board works really well. Okay, draw a generic quadrilateral. What's quadrilateral mean? 4 sides. So generic. So I mean, don't draw a rectangle or a square. Go more generic. So 4 sides, but make it a weird looking 4-sided shape. All the corners have to point out, so don't make it go in. 4 sides. 4 sides. It just says a generic 4-sided figure. All the vertices go out. So don't have it cave in. Do not draw something like that. I don't want that kind of look. I want all the corners to go out. Just a kind of random figure. I don't want a specific like square or something. Okay? All right, now with your protractor, measure all the angles in your quadrilateral. And then add them up. Measure all the angles. And pay attention to whether it should be more than. Think about, should that measure be the big number or the small number? And if you've just drawn straight hand, you might not get the right measurement. Measure your angles. You are a bad person.
I said shove it.
What? I said you're wrong. However, it can go either way. No, I don't know. So I think
Okay,
I was like throwing her off. I mean,
wow. Okay, what are we getting for totals?
Oh, it's just like balls.
Yeah, add them up and see. Ellie's got 360 and she's dying to find out if anybody else has 360.
I had 350.
You had 353,
I had 361.
361, 180. Ooh, that's quite a bit different. Do you have any obtuse angles in your thing? No obtuse angles? I'll bet you do.
You're not supposed to do that. You're supposed to have four sides.
Four sides and all corners, yeah, don't go in.
I have 357.
357,
360.
360. Okay, let's talk about should it be 360 or not. Okay, if you'll look up here, I can take my figure, and you can probably do the same, and draw in just one diagonal, not two. If I draw in one, that's divided it into two triangles. And every corner of the triangle is matching with a corner of the polygon. This one, you just have to put those together. So what should angles 1, 2, and 3 total? 180. How about 4, 5, and 6? 180. So all of those angles are the same as the quadrilateral. 180 plus 180. It should total 360. Now, if you're off by just a few degrees, like 357, 361, 358. Now, there's a little bit of error when you're drawing and measuring, but we can't be off like 100. That was probably using the wrong numbers. Okay, so what kind of shape should the angle measures add up to 360? Quadrilateral, right? Because you could make two triangles out of it. So that is stated in the quadrilateral interior angle theorem. Okay, so that's our theorem for your lesson. The sum of the measures of the interior angles of a quadrilateral is 360 degrees. So instead of triangle sum theorem, we're going to say quadrilateral sum theorem. The sum of the measures of the interior angles of a quadrilateral is 360 degrees. Thinking back to your figures that you measured, were there any two angles that added up to 180?
Yes.
You had some? Did you have any two angles in your diagram that added up to 180? So evidently you don't have to have two that add up to 180 to get to 360. But if you do have two that added up to 180, Morgan, did it look like you had any sides parallel?
Yeah.
Okay, if you have two angles adding up to 180, those would be creating parallels if they're consecutive. So that doesn't have to happen, but it might have happened. So for your notes here, let's put some measures. This looks obtuse. So let's say that's 130 degrees. This one looks like 90 degrees. This one looks like about 70 degrees. So how many degrees are left for the remaining angle? Is it 70? So the remaining angle was 70 degrees also. So if we know 3 of them, you can subtract and find the 4th one. Otherwise, we might have some equations we need to do instead. Anyone still need the screen? Okay, so find the measure of the remaining angles. 88, 70, 120. What's the measure of the last angle? Don't shout it out, please. Put it on your board, and I'll not have you show until I say so. I don't want anyone cheating. What's the missing angle?
Hurry, put it down.
Oh.
Distracting. Okay, show me.
Thank you.
I think it should be 82. 278 for that last angle.
That's before you subtract.
How about, yeah, before you subtract it, so 360 minus 100 and, or 298?
Yep.
Is that what it was? Was it 62 or 72? Was it 72? I think it should have been. Was that 298?
I thought it was 78. Yeah, that's what I'm saying.
Okay, so 298 must not have been the right total. Okay, what was 70 plus 120 plus 88? 10, 278.
278.
I think I had a 9 there. 82 degrees is what it was. Okay, next one, find the missing angles. Okay, this one's a trapezoid look to it. So this one might be 140, and this would be 40. Let's make this one 152. Find the missing angle. Nope, not usually. Picture might not look like it matches the number. Show me. Those look good. 28 degrees. Okay, 28 degrees for that one.
Okay, and when you say the parallel part, which lines are you talking about?
The parallels would be this one and this one. So these are like same side interior angles. But we'll get to that when we talk about the trapezoid specifically. Okay, and how about this one? Find the measure of the remaining angles. So there's a lot, I guess there's just one unknown. But it's not just X. Probably have to do more of an equation. What plus what plus what plus what equals what? Okay, show me. Okay, we've got a variety of answers on this one. Okay, we don't erase, we need to talk about this one. Okay, on this one, you have the angles all have to add up to how much? 360. And let's pull it back down a little bit. Okay, so the 2x, 90, 70, 50, those all have to add up to 360. Okay, what did 90, 70, and 50 add up to? 210? So 2x plus 210 has to equal 360. Subtract 210. 150. 150 equals 2x. So x would be 75. Now the question said find the angles. So if x is 75, this angle is 2 times 75. The answer that I was looking for was 150. All right, so setting it up like an equation, I think some of you added up the 210 and set that equal to x or 2x. All right, while I'm writing the assignment on the board, do this last problem. It has more variables in it.
I'm so excited to find out this assignment.
You have to wait until we get that problem done. So write the equation more rather than just trying to start calculating. 1 plus 1 plus what plus what equals what? I think you left out one angle. You left out this one. Correct. If I tell you correct, you can put that away and start on the 1 to 27.
Easy.
Yes, yes. Some more boards?
Are we gonna need the protractor and all that stuff?
No.
Hurry up, Brenda.
Some more to see here?
Oh, okay.
All right, I think we all got to the end of that one. X was 50. Okay, I think some